Okay, so problem number 6. Find the Fourier transform of f of x equals 1 minus mod x for mod x less than 1, 0 for mod x greater than 1, and hence find the value of integral 0 to infinity sin square t by t square into dt. So this is the problem number 6 of your complex Fourier transformation. So let us see how to solve. Solution. First, I'll write the given function as. So here the given function is f of x. F of x is equal to, it is 1 minus modulus of x for mod x less than 1 and 0 for mod x greater than. So this is the function. Now this is equal to. See, already I told in the last class, when I have a function like this, I mean mod x is there, so we have to rewrite the function. And here first the preference will be given for a mod x which is present in the limit, and then we'll think about mod x present in the function. I mean, first I'll simplify this mod x which is present in the limit, I'll rewrite a function, and then I'll think about what happens to this mod x in the function. So let us rewrite it like this. I'll write this as 1 minus mod x, comma. See here, you know, it is mod x less than 1. See, mod x less than 1 means it is understood. It is x lies between minus 1 to plus 1. So I can write this as minus 1 less than x less than plus 1. Right. So mod x less than 1 can be written as minus 1 to plus 1. And this is 0. The second is 0. I'll write this as otherwise. So the reason is, you know, clearly in the last 2-3 problems we did the same thing. So here the function exists only in this limit mod x less than 1, which is minus 1 to plus 1. Right. So this is 1 minus mod x here in minus 1 to plus 1. But in other limits, the value is 0. So I'll write 0 otherwise. That means the limit exists only in this part. So all other values become 0. So I'll write otherwise here. So let us rewrite a function like this. So the mod x present in the limit was simplified. So once you write the function in this form, we know the Fourier transformation of a function f of x, or I can say it is f of u, is calculated by the formula. It is integral minus infinity to plus infinity. It is f of x into e power iux into dx. Right? So this is the Fourier transformation formula here. Just a minute, guys. Due to some call, it was disconnected. We just connect it again. Okay. So we written the formula of Fourier transformation f of u equals. Now you know that this formula contains minus infinity to plus infinity, but the function is defined only in minus 1 to plus 1. So straight away I can replace this minus infinity to plus infinity by minus 1 to plus 1. So I'll write like this. So this is equal to it is integral minus 1 to plus 1 f of x e power iux into dx. Right? So we replace this limit by minus 1 to plus 1. Now in this limit, you know what is f of x? 1 minus mod x. Let us substitute. If I substitute and integrate, we get a Fourier transform. But how to substitute and integrate? Here, the limits are minus 1 to plus 1 and the function is 1 minus mod x. Mod x. Okay, so minus 1 to plus 1 f of x. So the f of x is 1 minus mod x. Okay, and the limits are minus 1 to plus 1. And you know, in the limit minus 1 to plus 1, this mod x will take two values, plus x and minus x. Because this minus 1 to plus 1, just observe this, minus 1 comma 1 can be bifurcated by putting a center point 0. So whereas this minus 1 to 0 is a negative interval, whereas the 0 to 1 is positive. That means in minus 1 to 0, the mod x value becomes minus x, and in 0 to 1, the mod x value is plus x. So what I am going to do is, I split this integration as integral minus 1 to 0, integral minus 1 to 0, it is f of x, it is f of x into e power iux dx, e power iux into dx plus integral 0 to 1, it is f of x into e power iux into dx. Right? This minus 1 to plus 1 can be divided as two subintervals. One is negative interval, it is minus 1 to 0. Another one is positive interval, 0 to 1. So let us divide the interval like this. This is negative, this is positive. And you know that in this one, in minus 1 to 0, this mod x will be equal to minus x. It is a negative interval. And in 0 to 1, the value of mod x will be equal to plus x. So using this fact, I can write this as, therefore, f of u equals, it is integral minus 1 to 0. So what is f of x here? It is 1 minus mod x, and you know mod x is nothing but minus x here. So if I put minus x in this one, minus of minus, it is 1 minus, mod x is minus 1. So it is, I'll write, okay. So 1 minus of mod x is minus x into e power iux dx plus the next one, integral 0 to 1. So integral 0 to 1. So this is 1 minus, so here mod x is plus x into e power iux dx. Right? So here I have substituted mod x as minus x for the first one, and here mod x is plus x. So simplify this and integrate now. So this is equal to, it is integral minus 1 to 0. See, this is 1 minus into minus plus, it is 1 plus x into e power iux dx plus second one, integral 0 to 1, say it is 1 minus x into e power iux dx. Right? So this function was simplified. Now if you observe, in both the integrals you have a product here. So once you have a product, you know you have to apply Bernoulli's rule. To apply Bernoulli's rule, you know you're going to select u and v, and exponential always represents v. So other one represents u. So let us select u and v like this and apply the Bernoulli's rule of integration. So if I apply the Bernoulli's rule for this, we get. So this is equal to, so I'll integrate the first term. So Bernoulli's rule says the first term is u v1. So u means 1 plus x into v1. v1 means integration of e power iux. So integration of e power iux is, it is e power iux by I into u, first term, then minus, differentiate this, integrate this, second term will come. Differentiation of 1 plus x, 1 is 0, x is 1. So it becomes 1. So integration of e power, it is e power iux by square, I square u square. So this is by using Bernoulli's rule between the limits -1 to 0. Now similarly for the second one, so it is u means 1 minus x into integration of e power, it is e power iux by I into u, then minus, so differentiation of 1 minus x, 1 is 0, x is 1 here, so you get minus here, minus 1 into integration of e power, it is e power iux by square, I square u square. So this is between the limits 0 to 1. Right. So this is by using the Bernoulli's rule of integration. Now let us substitute the limits. See, if I substitute the limits here, we get, this is equal to, see first, I'll substitute a limit for this function. Wherever x is there, I'll put 0, upper limit. If I put x is equal to 0 here, so this is 1 plus 0, 1. 1 into here e power 0, and e power 0 is 1, 1 into 1, 1. 1 by iu, the first term, 1 by I into u. Next, coming to this term, you put x is equal to 0, it is e power 0, e power 0 is 1, 1 by I square u square. So straight away I'll write here 1 by I square u square, but you know I square is minus 1, minus into this minus, it is plus, correct, it is plus 1 by u square, plus 1 by u square we get. So this is by putting upper limit for this. Next, lower limit, put x is equal to minus 1. If I put minus 1 here, it is 1 minus 1, 0. So this term becomes 0. So upper limit minus lower limit. So it is minus 0. Now put minus here. So here upper limit, okay, I'll simplify this. If I put minus here, it is e power minus I into u by I square u square. But you know I square is minus 1. Minus into this minus, it becomes plus. Plus into upper minus lower. One minus will be there. This minus. This minus is from the limits of upper minus lower limit. This minus into this minus. It is plus. Plus into I square is minus. So you get minus only. It is e power minus I into u by u square. So this is by putting lower limit for this. So upper minus lower. Now coming to the second term, put x is equal to 1, upper limit. If I put 1 here, 1 minus 1, 0. So the first term was 0. Okay, so we'll continue this. Okay, so upper limit, when I put x is equal to 1, it is 0. Now put x is equal to 1 here. See, this minus into minus, it is plus, plus into outside plus, it is plus. This term was plus, plus, x is 1 means 1 into e power iu, it is e power iu divided by, see here you get I square u square, but I square is minus 1. So here you get plus into this minus. So this term I can write it as minus. Okay, so I'll write minus here, minus u square. Correct. So this I square, since it is minus, so the plus becomes minus 1, minus e power iu by u square. This is by putting x is equal to 1, upper limit. Next, lower limit, put x is equal to 0. See, minus lower limit. When I put x is equal to 0, it is 1 minus 0, 1. 1 into e power 0 is 1. 1 by iu. It is 1 by I into u. Then minus lower limit. This is minus. See, here if I put x is equal to 0, this is 1. 1 by I square u square. But I square is minus 1. Minus into this minus plus. Plus into this minus minus. Minus into this minus. It becomes plus. Correct? I square is minus 1. Minus minus gets cancelled. Minus into outside minus, it is plus. Plus 1 by u square. Plus 1 by u square. So this is by substituting a limit. So while substituting a limit, we should be very careful. Substitute properly. Now this plus 1 by iu minus 1 by iu gets cancelled. This term I can cancel. See, 1 by u square plus 1 by u square, it becomes 2 by u square. This is equal to, it is 2 by u square, and here minus e power minus iu by u square minus e power iu minus e power iu by u square. See, minus 1 by u square is common. Minus 1 by u square is common. So if I take common, what happens? This becomes e power minus we have taken outside. E power iu, e power I into u, and this becomes plus e power minus iu. Right. Now further, this is equal to, it is 2 by u square minus, it is 1 by u square into, so you know e power I theta plus e power minus I theta can be written as 2 cos theta. So it is 2 cos theta. Theta means u. So it is, this term is nothing but 2 cos u. Now here I can take 2 common. 2 by u square is common. So I can write this as, so I'll write this as, I'll go to the next page. Therefore, f of u equals, see this 2 by u square common, so I get 1 minus cos u. But you know 1 minus cos theta is nothing but 2, what is 1 minus cos theta? 2 sin square theta by 2. Right, 1 minus cos theta is 2 sin square theta by 2. Use this formula. So this is equal to 2 by u square into 2 sin square theta. Theta means u by 2. Now this 2 into 2, it becomes 4. So therefore we get f of u equals, it is 4 sin square u by 2 divided by u square. And this is the required Fourier transformation of your problem. So for this problem, this is the required Fourier transformation here. This is how we can find the Fourier transformation for your question number 6. So same procedure, whatever we did in the last 4 problems, same thing we did, but here first we have simplified this modulus present in this limit. We have written like this, and then this mod x was simplified in the integration part. So in minus 1 to 0, mod x is minus x. In 0 to 1, we have taken mod x as plus x. We have substituted, then Bernoulli's rule is applied and integrated. So finally, we got the Fourier transformation. F of u is equal to 4 sin square u by 2 into u square divided by u square. So this is the Fourier transformation. This is how we can find, very important. Now, in addition to this, in this problem, we need to find the value of this integral 0 to infinity sin square t by t square dt. So let us find the value of that. So just a minute. So to find, so now I'll write, to find the value of integral 0 to infinity, it is sin square t by t square into dt. So I want to find the value of this definite integral using what? Inverse Fourier transform. Right. So to find the value of this definite integral, we have to apply inverse Fourier transformation. So let us use inverse Fourier transformation and find. Now, we know that by inverse Fourier transform, f of x equals, what is the formula of inverse Fourier transform? F of x equals, it is 1 by 2 pi integral minus infinity to plus infinity. It is f of u into e power minus iux into dx. Sorry, du. Du. E power minus iux into du. This is the inverse Fourier transformation. Now substitute for this f of u. Substituting f of u, we get, substitute f of u now. So f of x equals, it is 1 by 2 pi, 1 by 2 pi, integral minus infinity to plus infinity f of u. It is 4 sine square u by 2 divided by u square. So the f of u, what we got here, we have substituted into e power minus iux into du. E power minus iux, sorry, iux into, this is ux. Okay. Now, if you look at this integral given, here there is no e power term. But in this one, there is an e power term. Already I said in the previous 2-3 problems, if e power is not there here, only this function is there, which is present here, same type of term is there, means this e power should be eliminated. So you have to choose the value of x such a way that this e power will eliminate here. So for what value of x it will eliminate? So I can put x is equal to 0. So that e power 0 becomes 1. So I'll put that. So put x is equal to 0. So here in the left hand side, so you get x is 0 means f of 0, f of 0 equals. See the right hand side, see this is 2 and here 4, I can cancel, 2 2s are, right? So therefore I can write 2 by pi integral minus infinity to plus infinity. It is sine square u by 2 divided by u square into e power 0 is 1 into du. Right? Because e power 0 is 1 here. E power 0 equals 1. Right. Now further, you know that minus to plus can be written as 2 times 0 to infinity, because this becomes an even function. So because it is an odd, means nothing will come. So always you're going to get even functions only. Whenever they ask you to evaluate, apply the property of a definite integral. So integral minus to plus can be written as 2 times integral 0 to infinity. So I'll write the right hand side. This is equal to 2 by pi into 2 times integral 0 to infinity. It is sine square u by 2 divided by u square into du. So the right hand side was written like this. Now what happens to f of 0? See, f of x is, see here already we know f of x is 1 minus mod x in minus 1 to plus 1. Correct, in minus 1 to plus 1. And this is in minus 1 less than x less than 1. And x is equal to 0 means it is in between minus 1 and plus 1. So if you put directly the value here, because in this limit 1 minus mod x is there, means 0 is in between these two, in these two. So directly I can put 0 here. It is 1 minus modulus of 0, that is 0. So the answer is 1. F of 0 is 1. I'll write that 1 here. F of 0 is 1 here. Now simplify this and cross multiply. If I cross multiply this, it becomes pi divided by 2 into 2, 4 is equal to integral 0 to infinity. It is sine square u by 2 divided by u square into du. Right? So pi divided by 2 to the 4, integral 0 to infinity sine square u by 2 by u square. But what we want here, I want sine square t. Correct. So what I'm going to do is I'll take this u by 2 is equal to t. So let us put u by 2 is equal to t. So therefore u becomes 2t. So therefore du becomes differentiation of this 2 into dt. Correct? U by 2 equals t, u is 2t, du is 2dt. Now limits, when I put u is equal to 0, 0 by 2, 0 only. If I put infinity, infinity by 2 is also t is infinity. So the limits will not change. So directly I'll write. So therefore, pi by 4 equals, it is integral 0 to infinity sine square u by 2 is t by u square. U square means what? U is 2t, u square becomes 4t square, correct, using this into du. What is du? 2 into dt. So it is 2 into dt. So if I simplify this here, this 4 on either sides I can cancel. This 4 on either sides you can cancel. And this 2 we will take it to the left hand side. So if I take it to the left hand side, we get this implies. So I'll take this to the left hand side. So therefore we get integral 0 to infinity. It is sine square t by t square into dt is equal to pi divided by 2. And this is the value of your definite integral. This is the required value of this integral. So this is how we can find the value of this integral using inverse Fourier transformation.